My name is Muhammad Rean, and from New York High School. The project was on AI-powered non-invasive diabetes diagnosis and prediction using sweat biomarkers, and I was mentored by Dr. Subham Kumar. So the aim of this project was to develop a fully non-invasive system to diagnose diabetes. So we implemented AI and sweat analysis and we made a framework. So the goal of this project was to create a system to diagnose diabetes without any use of blood. Some background. So diabetes is a global issue. Over 500 million people have it, and it's currently increasing day by day. And some common methods that we use to diagnose diabetes is a finger prick test, which is invasive and it's really painful for some people. And this can lead to people not wanting to get the diabetes diagnosed, which can lead to even worse health outcomes. So what we did was create a non-invasive monitoring system, which is painless, and it solely uses biomarkers that is found in our sweat, so like glucose or lactate. And with this, we created a system that could diagnose diabetes with just using a sweat. So what we did was create a synthetic data set of 500 samples, and we implemented 4 key biomarkers that's found in our sweat: glucose, sodium, pH, and sweat rate, and we labeled each of the samples as diabetic or not. We used k-means clustering to which told us that the optimal amount of clusters there are is 3. And with this, we found hidden patterns and distinct health profiles for each of the clusters. We used min-max to normalize the data set and get rid of any mistakes inside the data. And we use 80 to 20 training split. So we use 80% training and 20% checking the accuracy. And with that, we implemented 3 machine learning models, which was logistic regression, random forest, and support vector machine. And we used gradient boosting regressor to predict a continuous future diabetes risk scores. So here's the outcomes. We found that logistic regression had the highest accuracy and recall out of all the other machine learning models. And support vector machine had the highest misclassification, and random forest had a balanced performance. And here's a chart. So as you can see, logistic regression has 0.97 accuracy, which is highest of them all, and recall of 0.9666, which is the highest out of all the other models. And here's just a chart to show. We also developed our risk prediction system. So we used about 100 samples, 100 individuals, and we created the data so it is like modeled after like 6 to 12 weeks of how the data would change over time. We use psychological like patterns to like develop the data so like it models the real thing. What this does, like the model takes an input of sweat glucose, sodium, pH, and sweat rate, and it looks at how it changes over time, and it gives you an output probability score of 0 to 1, which tells you the likelihood of the person developing diabetes. So you can see 0.0 to 0.33 is low risk, and it tells you the response, and 0.67 to 1 is high risk, and it tells you the response, and it's moderate risk for 0.34 and 0.66. So in this study, we successfully combined sweat biomarkers and machine learning to create a non-invasive diabetes diagnosis and risk prediction. In this study, logistic regression had the highest performance of 96.7 recall and almost perfect accuracy of 0.97. We also developed a risk prediction system, which personalized risk levels to recommend you a prevention to your diabetes. You can be at a high risk, and it'll tell you to go to a clinic, or you could be at low risk and tell you how you can prevent future diabetes if it occurs. You can also we can also implement this study into wearable sensors in an app. So this can tell you if you're at a risk of diabetes and your sugar levels through your sweat, which this can be really useful for people that don't want to get their diabetes diagnosed with finger prick, because they have to blow a hole inside their finger and to take blood out, and they have to check in. Some people really don't like doing that. This research presents a complete non-invasive framework and a diabetes diagnosis and risk prediction using sweat biomarkers and machine learning. We logistic regression had the highest performance, and we also developed a risk prediction tool, tell the patient if they have diabetes or not. This study can also be implemented in a mobile application, which can be used as wearable sensors to tell you if you have diabetes or not and your glucose levels. And so this study does acknowledge limitations because we use synthetic data, which we created. So this may like have a little bit inaccuracy to on the actual data. So in the future, someone can actually conduct this again with actual real life data. We couldn't actually find real data with like people that actually conducted research with sweat biomarkers. It was like really limited, and it wouldn't have worked with what we implemented. So what I found most valuable is the connection I made with the mentor. My mentor, like he helped a lot with like explaining like each concept and was really patient because like research to me was very new, and also he laid out all the groundwork and everything I need to get done. One of the most important experience and knowledge I learned was how to write a research paper. Before joining YRI, I had no experience in research whatsoever. And what I also learned was implementing machine learning and applying it, models, and figuring out data and analyzing it.